Okay, welcome to section 9.2. We're going to talk about quadratic inequalities in one variable. Okay, so what does this mean? Recall from 9.1. From 9.1, we were dealing with linear inequalities in two variables. Because it was in two variables, the range of solutions typically indicated some solution region, okay, that looked like that. Now that we're working in one variable for quadratic, so this is 9.2, graphically what your solutions will look like, suppose we have some kind of quadratic. Your solution, since it's in one variable, which is going to be an x, it will simply be on the x-axis. So suppose the solution was only between these points right here. Okay, that's the graphical representation of a one-variable solution. A two-variable solution set would basically be a two-dimensional image as opposed to one-dimensional image. Okay, so it's like 2D versus 1D in terms of dimensions. Okay, so in this one we're just basically going to go and solve quadratic inequalities in one variable. We're probably not going to graph it. Okay, I prefer not to graph it. I'll show you the first one. I'll show you a graphical representation. But basically the idea here is to solve. Okay, so let's take a look. You have various cases that can occur. Don't worry too much about them. Okay, I highlighted them here so that you know them, so that you're aware of them. But you're going to see that this is actually not too bad, and that these cases just appear from when you solve the inequalities. Here are the three possibilities that can happen. You can have no value solutions. Okay, so nothing satisfies the inequality. You can have a one value solution, or you can have an infinite number of values that will satisfy the inequality, which is typically the case, okay, in most applications. So let's take a look. So your questions will look something like this: solve x squared minus 2x minus 3 less than or equal to 0. This is an example. I highlighted two ways of doing this. The first way, you can graph. So method 1, you can graph. The problem with this, or not the problem, but the inconvenience is the time it takes to graph. Okay, so for instance, back to this question, you would have to complete the square to find the vertex. Once you find both of the roots, you then can graph it. It takes a bit of time, but it's not a big deal. Look back at chapter 3 if you want to reference how to do that. But once you have that, you can visually look at the solution, because the question here is, when is this boundary, x squared minus 2x minus 3, less than or equal to 0? Okay, so in other words, when does this graph dip below the axis? And it dips below the axis right here. Okay, and since we're in an equal to, right, less than or equal to, this is your solution. So the benefit of method 1 is once you graph it, you're pretty much done. You just have to take a look at the solution. Then you just have to report it in set notation like this. Okay, so between -1 and 3, for x is where your solution set is. Method 2, though, won't rely on graphing. It will rely simply on finding the roots, because all you really care about are these 2 points right here. Okay, those 2 points there are all you care about. And then you're basically going to select a point from this region, a point from this region, and a point from this region. Okay, less than one of the roots, greater than or in between both roots, and then greater than this top root, and see where the inequality is satisfied. Where the inequality is satisfied is where the solution is. This will look like this. So you can pick any point over here, see if it satisfies, any point over here, see if it satisfies, any point over here, see if it satisfies. And this is simply by finding the roots. Remember, finding the roots is easy. You just have to factor it or plug into the quadratic formula. Then your test points will tell you, does it satisfy it? No. This one, yes. This one, no. Remember, this is between the roots. This is greater than the root. This one over here is less than the root. and then you're done. Then you know the answer. Okay? I prefer method 2, as I said. So here we go. Let's solve x squared minus 10x plus 16 is less than or equal to 0. So I'm basically I'm going to factor the corresponding quadratic equation. And what that will look like is x squared minus 10x plus 16 is equal to 0. Let's factor this, guess and check, which is going to be 8 and 2. We'll make 10 as long as they're both negative. That will multiply to give you positive 16. Therefore, the roots are 8, positive 8, and positive 2. Now, we draw our number line. So this is step 1. This is step 2. Okay, you draw your number line and you place the roots on the number line. Because we're using an equal to sign, okay, less than or equal to implies solid circles on the roots. Because we're using an equal to sign, where we place the roots, we're going to use solid circles because they're included in the solution. So this is 2, this is 8. Okay, this is kind of like a zoomed in image on the x-axis, right? The graph, or the quadratic, just so you can kind of have an idea, is looking something like this. And we're kind of zooming in onto the axes. You don't have to worry about doing that little sketch, but I'm just trying to show you what this graphically looks like, because we're kind of doing a mid-range graphical representation of what's going on here. So we need to select points that are less than 2. So I'll select 0. I'll put in red what I'm going to select. This one I'll select 3, and this one I'll select 9. Okay? Any points are fine. So for x equals 0, you're going to plug this into the equation to get 0 squared minus 10 times 0 plus 16. Is this less than or equal to 0? Well, let's simplify. We get 16, and that's not less than or equal to 0. So the inequality is not satisfied for x equals 0. So anything left of 2 doesn't satisfy. And for x equals 3, sorry, we're going to have 3 squared minus 10 times 3 plus 16. Is that less than or equal to 0? Well, we're going to have 9. 9 minus 30 plus 16 is negative 5. Negative 5 is less than or equal to 0. So yes. And you can kind of imagine this next one is probably not going to work because we have our 2 roots. By the way, you can't choose 2 and 8 for these test points because you're on the roots, which will give you no information because they must satisfy this equation. You know they satisfy it. They actually make it equal to 0. That's what finding the roots means. So here you're going to have a larger number. So you can use a calculator here if you wish. We're going to have 81, a minus 90, which is negative 9, plus 16, which is 7. And this is, again, doesn't satisfy it. So your only solution is here. Between two and 8. That's the solution. Oops. Sorry for my poor writing. So your solution set for this example would be the following. x such that 2 is less than or equal to x is less than or equal to 8, and x is an element of all the real numbers. Okay, there's an infinite number of solutions between these 2 points. Okay, so that would fall into that case. But here's the answer. Just like that. Okay, so it's pretty straightforward actually. All the examples that we're going to do are pretty much identical to this. We're going to do 2 more, and all we're going to do is we're going to change the value of a. Here we're going to make it negative. Okay, but really there's no difference. So when we do another example and we have negative x squared plus 3x plus 10 is less than 0, so this time we're going to use open circles at the roots, because the root itself will not satisfy the inequality. And to start off, we're going to factor out that negative in front of x squared. And really we're going to find the roots. So step 1 is finding the roots. Okay, so you're going to divide both sides by -1 to get rid of that negative coefficient. And now you can go ahead and factor this. I'll factor it up here. You get x minus 5 and x plus 2. Therefore x equals 5 and x equals -2. Okay? So from here, you're going to draw your number line. So step 2 is drawing the number line. And you're going to place your roots with open circles, -2 and 5. Okay? This time the quadratic, by the way, looks something like this because it's pointing downwards because of this a is negative. So we're going to choose some points. I'm going to choose -3 because it's quite small. Between -2 and 5, I'm going to go for 0. I always try to go for 0. And I'll choose 6. Okay? So for x equals -3, what do we get? We get negative, and I'm going right from the start here. Right from the start. Negative 3 squared plus 3 times -3 plus 10, which is equal to -9 minus 9 plus 10. Okay, I just want to point out here that you're going to have 9, but the negative stays out front. That's why it's -9. Okay, so I can be clear there. Minus 9 plus 10 equals -8. Is that less than 0? Oh, yes it is. Yes, so it satisfies it. So, based on your experience of working with the previous example, what do you think the solution will be? Okay, we know this is this is part of the solution. Can you imagine it being also inside here? Probably not. My guess is it's going to be on the opposite side, so a greater than 5, but not in between -2 and 5. That's my guess. Okay, so for x equals 0, you're going to have -0 squared plus 3 times 0 plus 10, which equals 10. Is that less than 0? Nope. And then x equals 6. I'm assuming this is going to satisfy it. So when you plug it in, you're going to get -36 plus 18 plus 10 gives you -8. Less than 0? Yes. Therefore, there's our solution, you guys. On either side, so your solution set. Your solution set will be x such that, let's see here, x is less than -2, or x is greater than 5. And again, x is an element of the real numbers. Okay, that is your solution set. I'll box this off so it's easy to find. So hopefully that made sense. So, really there's nothing special about that example. Moving on to the last example, all we're going to do this time is I just want to point out that if you have a constant value on the opposite side of the inequality, you have to rearrange. So here you have to rearrange first. And this will change everything. If you don't do this, you're going to get this wrong. And I'll show you why. So you have to do this first. Now when you try to actually factor this, you're going to realize you can't. Okay? Can't factor. Okay? Therefore, we're going to use the quadratic formula. I just wanted to point out, so that when you're doing some practice problems and you're saying, oh, I can't factor this, you didn't do any examples where this was the case, here's the example where, of course, you can use the quadratic formula for everything. And it's particularly for this one you have to. So here we have a equals 1, b equals -4, and here's why you have to rearrange there, because c is equal to -10, not +10, because you move it over, because you're in standard form here. Therefore, x is equal to -4 plus or minus the square root of -4 squared minus 4 times a times c, which is -10, all over 2 times 1. When you factor this, or sorry, when you simplify this, you're going to get an answer of x equals 2 plus or minus square root 14. Okay, which translates to be 5.7 roughly, and roughly -1.7. Okay, I'll leave the computation to you. When you put them on the number line, we're not in an equal, so we're going to use open circles again. And this is -1.7 roughly. This is roughly 5.7. Okay. So we can use values between them, which will be 0. Below them, we can pick -2. We can pick 6. So for x equals -2, we're going to have -2 squared minus 4 times -2. You can go back to the original if you want. I don't know why I have an equals sign here. You can go back to the original, which will be, so I just want to fix that, which will be, is this greater than 10? Is this greater than 10? Tough to say. Let's see. 4 minus 4 times -2 comes out to be 12. So 12 is greater than 10? Yes. Therefore, this is a solution. What about x equals 0? We get 0 squared minus 4 times 0. Is that greater than 10? 0 greater than 10? Nope. No. And then for x equals 6, we have 6 squared minus 4 times 6. Is that greater than 10? Well, we're going to have 6 squared is 36 minus 24 is 12 again. 12 is greater than 10. Yes. Therefore, once again, we have a similar solution set to before. But this time I want to have an exact solution. So please don't use these approximations, okay? Go back to the exact roots, which will look something like this. X such that x is less than 2 minus square root 14, or x is greater than 2 plus square root 14, where x is an element of the reals. Okay? And that would be your solution. Try to fit it in one line. I ran out of space. But that's that. Okay? So that is section 9.2. Pretty straightforward. There's really no variations. Practice hard, and when you're ready, move on to section 9.3.